Hello, everyone, and welcome to Calculus 2. My name is Dr. Jose Villalobos, and I will be your instructor this semester. We're going to start with section 6.1. We did something similar in Calculus 1, so this is a more general idea of what we did in Calculus 1. Remember, in Calculus 1, you have something called the fundamental thermocalculus, which tells you that if you want to find, for example, the area of any function, but let's say x squared from, 1 to 4, so you want this area. And the fundamental theorem of calculus, it just tells you that the area is the integral from 1 to 4, or the antiderivative of x squared dx, which will be x cubed over 3. This is the antiderivative, and then you plug in the limits of integration. So this should be 1/3 times 4q minus 1q squared, which will be 64 minus 1 is 63, so it should be 63 over 3 square units. So that's what we did before. Now in calculus 2, we have something very, very similar, except that now you have two functions. The upper function is going to be called f of x, and the lower function g of x, or you can interchange them. It doesn't matter. So the point is, this is the upper function, and this is the lower function. So therefore, in general, when you have that, so in general, if that's the case, the area is going to be the integral from, let's say this is going from a to b, is the integral from a to b of the bigger function minus the smallest function. And then just integrate the usual way we did this before. Now, if you look closely to this one, the problem I just did right now, so notice that if you have x squared, so if f of x is equals to x squared, essentially you have another function here, which is y equals to 0, or you can technically say that this is g of x. So therefore, notice that if we plug it into this equation, the area would be the integral. So we were going from 1 to 4, from 1 to 4 of x squared minus 0, or just 0 dx, which is exactly the same thing we did before. Okay, so the difference now between calc 2 and calc 1 is that you will have more than one function. Before, all the cases were similar to this, and now we're going to have two functions or more sometimes. Okay, all right, so here's a typical example. It's very important that you recognize these functions. Here we have f of x is equals to x squared, and g of x is equals to the square root of x. So clearly in this graph, the biggest function is this one with the square root of x. Now we need to figure out where they intersect, because that's going to give you the limits of integration. For that, you need to find where the two graphs are equal to each other. So the intersection is where f is equals to g. So intersection, remember, means f is equals to g. So in our case, that means that x squared is equals to the square root of x. There are several ways to solve this, but factoring is probably the most useful. All right, so here, if we factor this, notice you can factor the square root of x. So to get x squared, you need to have x to the 3/2. Why? Because 1/2 plus 3/2. Remember that this is x to the 1/2. This will give you 4/2, which is 2, and then minus 1. So from here, this means that radical x is equal to 0, which implies that x has to be 0, which is this point right here, or x to the 3 halves should be equals to 1. The only solution to this is x equals to 1. So therefore this is equals to 1, and hence the limits of integration go from 0 to 1. So then the area, remember we take the biggest function, which is square root of x, and the smallest one, which is x squared. And this is a pretty simple integral. Recall from calculus 1 that the square root of radical x is x to the 3 halves times 2 thirds, and the integral of x squared, or antiderivative, is x cubed over 3. The limits of integration are from 0 to 1. So therefore you plug it in here, you plug in 1, you will get 2 thirds minus 1 third. Why? Because anything to the 1 to any power will give you 1, so 1 times 2 thirds is 2 thirds. And here you'll have 1 cube, which is 1 over 3, is 1 third. And then you plug in 0, this will be just 0 minus 0. So the whole answer is 1 third, and that's it. All right, let's do another example. Here you have two functions. Which one is f, which one is g? I told you it doesn't really matter. You just have to make sure that you understand which one is the top and which one is the bottom. Here it will be easier to rewrite this as y equals to x minus 1. So this is one function, this is the other function. So first we need to find the points where they intersect, just like we did in the previous example. And for that, remember you had to make or set the two equals to each other. So in this case you have x minus 1. The square root of that should be equals to x minus 1. So then to get rid of this, remember from pre-calculus you square both sides. The square cancels the square root, so you end up with x minus 1. If you FOIL here, you end up with x squared minus 2x plus 1. Remember that this means x minus 1 times x minus 1, and then you distribute, you'll end up with this. You should definitely check. Then, since this is a quadratic equation, you have to move everything to one side. So let's move everything to the right side. So we need to subtract x and add 1. So subtract x and add 1. So the left side will give you 0. This will be x squared minus 3x plus 2. And then we just need to factor this. This is x minus 2 and x minus 1. So the solutions are x equals to 2 and x equals to 1. So that means that's the two places where they intersect. So you have, let's say, 1, 2, 3. Let's say this is 1, this is 2. So we already know they're going to intersect at the point 1 and 2. So next, let's do the graphs. This is just a line. So just create a quick table. So let's say that if this is 0, well, this will be minus 1. If this is 1, this will give you 0. So all you need is 2 points for this one. Since this is a straight line, so you have 0, and let's say this is minus 1. So this will be the first line. Okay, so I'm just going to call this one g of x. And therefore this will be f of x. Now for this one, you similarly can do a table, x, y. So notice the smallest number you can pick is 1. If this is 1, this will give you 0. And then I want to pick 5, y 5, because 5 minus 1 is 4, and the square root of 4 is 2. So therefore, you can also pick, like, for example, 2, and this will give you 1. So when this is 2, this is 1. And since this is the square root, it looks like this. So essentially, the question is asking you to find this area. The reason why the graph is important is because you need to see which one is the upper and which one is the lower function. So here clearly the square of x minus 1 is the upper one. So then to find the area, this will be the integral from 1 to 2 of x minus 1 minus x minus 1 dx. Notice that this is the same thing as just minus x plus 1, so that will make it easier to integrate. So if you integrate this part, is very similar to the previous one. This should give you 2/3 times x minus 1 to the 3/2. You use substitution, and then minus x squared over 2 plus x, and the whole thing goes from 1 to 2. Once you plug in the values, this should be 2/3 times 1 to the 3/2 minus 1 squared over 2, 2 squared over 2 plus 2, and then you subtract 1. Notice that this will give you 0 for the first one, and then the second one will give you 1/2, and the last one plus 1. All right, so now let's do a example that's a bit more tricky, involving trigonometry. So let's say that this is g of x and this one is f of x. Again, it doesn't matter which one is which, as long as you know which one is the top, which one is the bottom function. So let's say that this was pi over 2. This one is pi, 3 pi over 2 and 2 pi. Okay, so let's graph first cosine. So remember the graph of cosine, let's say that this is 1, so therefore this is minus 1. The graph of cosine does this. This is another function that is very important that you know how to graph. So that's the graph of cosine. And then if you do 1 minus 2 cosine, it's a good idea, like I told you, to do a table. It's not mandatory, but it will make life much easier. So for example, if this is 0, you're going to have, this is 2 minus 1, which is 1. If this is pi over 2, it's going to be 2 minus 0, which is 2. If this is a pi, it will be 2 minus 1, which is 3. If this is 3 pi over 2, it will be 2 minus 0, which is 2, and so forth. This is 2 pi, this is 2 minus 1, which is 1. Okay? So then the graph for that one is going to look like this. Let's say this is 2, this is 3. The highest is going to go is 3 at pi. And the graph is going to look like this, which kind of looks like the mouth of a shark, something like that. All right, but clearly, remember that this keeps going, so that's this. This is the area that you want, okay? And clearly, the top is this function, and the bottom is just cosine. Okay? So therefore, if you want the area for this, the area is going to be just the integral from 0 to 2 pi, so it's from 0 to 2 pi of 2 minus cosine x minus cosine x. So notice that you can simplify this to the integral from 0 to 2 pi, or just 2 minus 2 cosine x dx. This is a pretty straightforward integral. This is 2x minus 2 sine x. Recall that the antiderivative of cosine is sine. This goes from 0 to 2 pi. So this will give you 4 pi minus 2 times 0, because sine of 2 pi is 0. And then you plug in 0 in the whole thing, it will be 0 for this particular case. So the answer is just 4 pi. All right, so let's do another example. Remember that if you graph x to the third power, the graph looks like this. This is another classical graph you need to remember forever. And x is just a straight line. Now it look like this. So here, I didn't do a pretty good job drawing this. There should be a little chover here, same thing here. So essentially you have two areas, this one and this one. And you can see that clearly they intersect at 1 and -1. So I'm gonna call this area 1 and this one area 2. So notice the intersection, let's just check that is -1, 1, and 0 actually. You have x cubed should be equals to x, which means x cubed minus x should be 0. You can factor the x, so this is x squared minus 1 equals to 0. This is x minus 1, x plus 1. So clearly the answers are 0, 1, -1, just like you can see in the graph. Okay. Now, here, if you look to area number 1, notice that for area number 1, the top graph is x. So therefore, this is the integral from 0 to 1 of x minus x cubed, which is equals to x squared over 2 minus x to the 4 over 4 from 0 to 1. And you can check that this is equals to just 1/2 minus 1/4 minus 0. So this is just 1/4. So that's the top area. So this is equals to 1/4. Now you look closely to this. These are symmetrical. I didn't draw the best picture, but this and this area are supposed to be the same. This is the top, this is the bottom. So notice what happens next. So then the second area is supposed to be now the integral from -1 to 0. And now the top area is this one right here, or the top function, sorry. So this should be x cubed minus x dx. So this will be now x to the 4 over 4 minus x squared over 2 from -1 to 0. So then this will be now 0 minus 0 minus, and then it's going to be -1 4 to the 4th power. Actually, let me see this. No, like this. If you plug in -1, it should be -1 to the 4 over 4, and then minus 1 squared over 2. Notice that this will give you minus, and then this is going to be 1/4 minus 1/2. So here you have this part is minus 1/4, so it will be minus 1/4, which is also 1/4. All right, so now let's do another example. This is a little more interesting for this reason. Look here, just pretend, or actually not pretend, this is the first function, f of x equals to the square root of x. Notice that this one would be g of x, which is minus the square root of x. So those are the two functions. And let's say you want this total area, which you can clearly see this is the same area twice. Okay, so this area and this is the same area. And let's say that x is equals to 4. So this has to be given. It could be any value. So in this particular case, the area will be the integral from 0 to 4 of the upper function minus the lower function. So notice that this is just the integral from 0 to 4 of twice the square root of x dx, which will be 2. We have done this integral several times from 0 to 4, and notice that this will be 4 over 3. You multiply this times that, and this will give you now 4 to the 3 halves minus 0 to the 3 halves, and the whole thing will be 4 thirds. 4 to the 3 halves is actually equals to just 8y. This is the same thing as 4 to the 1 half, which is the square root q. So this is 2q, which is 8. So therefore this is essentially just 32 over 3 square units, and that's it. Okay, so now you can actually also integrate with respect to y. This is something we haven't really done, or that you never did this in calculus 2. So notice that this equation is the same thing as this, okay? Or you could have done this. So now here you have to be more careful, because then the limits of integration are now with respect to y, and notice that this goes from minus 2 to 2. And if you look at this way, now you have two functions. This is the upper function, which will be x equals to 4, and the other function is x equals to y squared. So clear, this is the top. So this is the top function, and this one will be the bottom. Okay? So if we integrate with respect to y, which again something we haven't done, it will be this, minus 2 to 2. The upper function is 4, the lower function is y squared. But now we integrate with respect to y. This is 4y minus y cubed over 3, from minus 2 to 2. And you plug in the limits of integration, it will be 4 times 2 minus 2 cubed over 3, and then minus 4 times minus 2 minus 2 cubed over 3. And you should check the algebra, the arithmetic, and this is 32 over 3, which is no surprise because it has to be exactly the same area. So depending on the problem, this may be easier to cut it into two pieces, or this may be easier. So it all depends on how the problem is asked. You cannot really tell that until you try the problems. Okay. All right, let's go to the last two examples. This question is very similar to the previous ones. I think this is going to be one of your homework problems, so at least give me a quick idea. So here you're going to have three functions. One looks like this, the other one will look like this, a little more chubby, and then something like this. So you will have three functions. So just try this. It should be straightforward. I believe this will be one of your homework problems. So now let me do a example that is different, something that you may not seen before too. So here it is. So here they give you three vertices, 2, 0, which is right here. That's the first one. The other one is 0, 2, which is here, and then minus 1, 1. It's not there. Minus 1 and 1, so it's right here. And they want you to find the area of this triangle using calculus. Okay, so we're going to break this into two pieces. So this will be the first triangle, which I'm just going to call it the blue part, and then we'll have the green part. So this will be area 1, this will be area 2. So you need to figure out the equations of the lines using the points. You should check here that y is equals to x plus 2. This is just algebra. That this equation is y equals to minus x plus 2. To do this, you need to use 2 points to find the slope, which you can see that here. The slope is 2 over 2 is negative because it's going down. That's okay, negative x. And the y-intercept is 2. So you need to figure out these equations first. And the most messy one is this one. Y is equals to minus 1/3 x plus 2/3. Why do you need to know that? Because like all the previous examples, you need to know which one is the top, which one is the bottom, and then just plug it into the formulas. So here the total area is going to be area 1 plus area 2. So area 1 is going to be the integral from minus 1 to 0, which is the blue area, of x plus 2 minus the smallest one, which is this dx, the whole thing. And then you just need to integrate that. Should be straightforward. And then area 2 is going to be the green part. This is the top, this is the bottom. So it's going to be now minus x plus 2 from 0 to 2, then minus 1/3 x plus 2/3. These intervals are relatively very easy to do. For example, this one will be minus x squared over 2 plus 2x plus 1/3 x squared over 2 minus 2/3 x, or you could combine first and then integrate. So this is goes from 0 to 2. So it should be pretty simple. So the answer, remember, is going to be whatever you get from here to here. So just check the answer here. This should be very straightforward to finish these problems. And that's it for section 6.1. Well, one last thing. So remember, let's say that you want to figure out this line. Okay, let me do this one for you. For that one, the slope between those two, you can see that this is 1, 2, 3, and this is 1. So clearly the slope is, the rise is 1 and the run is 3, so it's minus 1 over 3. Now the y-intercept is a little more tricky. So that's why you can use any of the points. So let's say you use the point 2, 0. Remember, this is 2, 0. So you have y minus y1 equals to m times x minus x1. This is another equation from pre-calculus that you have been using in calculus a lot. So you plug it in here. This will be y minus y1, which is 0, equals to m, which is minus 1/3, and then it will be x minus 2. So therefore y will be minus 1/3 x plus 2/3. And that's how I got these equations. This one and this one are actually a little bit easier. All right, that's it for 6.1.